bi-dimensional array and object-oriented programming. Okay, because you guys learn to see how to develop a program from scratch. I'm going to do everything from scratch. There is no magic. You look, there's nothing under my sleeve. Okay, that's my wife. So I'm going to create. I understand that in the main I need to start playing, right? Okay, the game has to start. So I know that the game has to go forever until somebody wins. Is that true?
Yes.
Not necessarily. Maybe until there is a draw. If the table gets full and the game is a draw, it's done, right? Correct? But before having the two players engaged in the game, the table has to exist. The board has to be created. Right? So somehow I need to create a board. So I have to create a board. Then my pseudocode can start as simple as this. Start game. Right? Okay, that's it. So far. Is that hard?
No.
Yes.
Yes? Okay, maybe you should go to another professor. So, it's a create board, right? How the heck do I create a board? Well, that sounds like I need to create an object to handle the board. Okay, let me have a class that will be in charge of that. Not a problem. You call it whatever you want. Java class. You should be familiar with this already. Let me call it board, for example. Okay. Board,
Professor,
right?
can you close out the other programs while you start? Just for simplicity.
You want me to close all this? This is not my
Just the
laptop.
other tabs.
Oh, the other tabs. Yeah, those are the other tabs. Not a problem.
Not that one.
That's fine, that's fine. You can reopen it. No need stress. People are with the me already. Okay. Right? Okay, so we have done that. So my table is going to be of certain size. Okay, let's start playing with people are still laughing. So let's start creating our constants. Okay, I'm going to create constants to determine the size of my array. I want to put how many rows and how many columns, right? Okay, you know it's 3 by 3.
Yes.
But I want to make this game flexible because maybe in the future somebody wants to take my code and change it to 4 by 4. That's nice, right? So I'm going to create constants. How do I declare constants, guys?
Fine.
Final, but what do you have to write first? Constants are supposed to be constants. So they are supposed to be public, right? So you write public. Then, static. Okay, this is a penny thing I owe you. Just for now, just a little heads up, static means it's shared. Okay, meaning that it's the same value for everybody. Everybody shares the same thing. That's what static means. Everybody shares this attribute. That's what static means. Okay? We're going to see that in more detail soon. Okay? So stay tuned. So, find static final, and I will call it, say, n rows. Professor, why the heck would you call it n rows? Because I feel like it. So, the reason why I call it with capital n rows is because when you declare constants, normally you have to put them in capital. Okay? What am I missing? In, right? Specify the type. And then here I put what's the value I want to use. Say 3. Right? I want to do the same for, say, number of columns. Got it? Okay. What else will I need to represent my board? Obviously I need to have a bidimensional array, because that's where my board will be stored, right? So let's create my bidimensional array. Well, attributes are declared with private, we talked about that before. I'm going to put a table of charts because I'm going to have a bunch of X and circles, right? Okay. Chart, I want to call it table, for example, and I will put just like that. Well, when somebody constructs the board, I can say table equal new chart, and here I will say how big I want it. N rows by n columns. That's why I use my constants. Right? So pretty much I'm setting up the table. So if somebody wants to make the table bigger, I just change those two constants and the constructor will make the table bigger. Is that clear? Yes? Okay. But when you create a table, Java is going to initialize each character with a default character, right? Is that what we want? Maybe yes, maybe not. So let's have ourselves a way of initializing the table, right? So say put spaces in all spots. Sounds good? So we're going to have another character to indicate, another constant to indicate what an empty spot means. Final, say char. I will call it empty. And I'll put, say, this character to signify an empty spot. Got it? And here we'll say initialize table or board, or just initialize. Since we're inside board, it's understood. So I don't know how the heck I'm going to initialize it. I just call it initialize. Right? So now if I want to see some lazy, I'm going to do that now. Value void initialize. Okay, what do I need to do is just go for every row and for every column and put an empty spot in each of them. Is that too hard? That's not hard. So you do for in I equals 0, I less than n rows. Professor, do you have to say n rows? Yes, or I can say table dot length just because I have already declarable. Whatever you prefer. Doesn't really matter. Okay? Just to refresh your memory from what we wrote on the board, I'm going to write length. So this will go for every row. You know that, right, guys? You know how to do nested loops to traverse by dimension, right? You know that? Yes? I need to go through every row, and for every row I need to go through every column inside. So when I put these two for loops here, I might explain this, but some of you look at me like, what the heck are you talking about? And then I'm going to say table of ij. I'm going to put an empty to everywhere. So, when I have two for loops, you know how they behave, right? When you have two for loops, the inside loop moves for every iteration of the outside loop, right? The inside loop will go over all of it for every single iteration of the outside loop. Meaning that, say I did 3 by 3, right? So I will go from 0 all the way to 2, right? We'll use the marker. Right? Correct? Now, for when I is 0, j has to go all the way, because j is inside. Got it? That's how a nested loop works, right? The inside has to do everything for every one of the outside one. Right? Got it? Some people are getting bored and telling professor you're getting old. Is that clear?
Yep.
Yes? Okay. So once I have done that, what I mean is the first combination will be 0, 0, right? The first ij will be 0, 0, right? So I'll be saying pretty much this table at 0, 0 equal empty, right? So this is my array, like this, I'm putting an empty spot here. And then I will go to 0, 1, I'll put an empty here, and then I'll go 0, 1, 0, 2, and I'll put an empty spot. Then I move to I1, so I'm moving on to this row, right? 1, 0 is here, right? Empty spot, and then 1, 1 is here, and so on and so forth. Is that clear? Yes? Yes, sir.
If you create a table, isn't it already creating an empty spot? Why do you have to create an empty?
Because when you create a table, an array of 3 by 3 in this case, it's initializing all the spots to a default character. It might be empty. But what if I want to, instead of putting an empty spot, somebody wants to say, you know what, for me empty spot has to be represented by an add. You can always change it, you know?
By what, you think?
Maybe they want to use an add symbol to indicate it's empty. It's just a matter of like. Got it? So far so good, guys? Yes?
Yes.
Okay, so I have initialized the table. Is that hard? Not really, right? Now, if I have a table, isn't it necessary to also be able to print the content of the table? Yes, it is, right? So I will say value void print table. So here, how do I print? Same thing, right? I have to go for every row and for every column, right? And I will say the system out. I will say print because I want to put all one next to the other, right? So I put print line, all the elements are going to come all below the other, right? So I will put a space between them and say I'll go table ij. Clear? Easy, right? Let's see if it does what we want. So we say create board is done. Sometimes if you don't want to complain, just comment them out. Just ignore them. Like when you fight with your girlfriend, you just ignore them, don't fight too much. And just stop. Okay. So you create your board. How do I create a board? So you say board, say my board, right? Equal new board. So far I have created a board, right? So say I want to print the board, so to make sure that everything got done, because when I did this call, what happened when I did this call? When I did this call, the constructor was called, right? So the table has been created of 3 by 3 in this case, and I have called initialize, so the table has a bunch of empty spots already. Got it? So I want to see if that table was created successfully, so I'm saying print board. I'm going to test now and say, my board, print table. I call it print table, doesn't really matter. I run it, and it's going to print here. You see? It's printed. Yeah, but I don't see it. Yes, because the end is kind of weird. So let's put this to make it more visible. Say Diana, for example. Or the end makes some people happy. Let's see if I can do it. Yes. That's how you guys can feel relieved. So I have a bunch of things there, right? Okay. So is that how we want it? No, really, right? Because what we would like is to put a change of line every time we finish a row, right? Correct? Because every time we finish a row, we should print the next thing on the next line and so on, right? Now, if you put here print line, you're going to screw it up because what you're going to do is print all the ends one below the other. That's not what we want either, right? We want every line, right? So it's good to put print. Now, at some point, I need to determine that I have gotten to the end of the row. That is not hard. That is easy. You know why? Because when you are here, check out where the cursor is. When you are there, where the cursor is blinking, that means that the whole columns have been all printed. The column is down. Right? If I am there, it's because the 4 above has finished. Correct? If I am at that point, it's because the 4 above has finished. Is that clear? So if I put a print line here, like this, even empty, so what it's going to do is, it's going to take I0, it's going to go over all J's, print all the columns, and then make a change of line, print a change of line. Then go, I equal 1, take all J's from 0 all the way until the end, all columns, and print them, and then system of line, print another change of line. Is that clear?
Yeah.
Yes? So when I run the code, it's getting a little more decent. You see?
I don't get it.
You don't get it? Okay. You have 2 for loops, right?
Yeah.
When I is 0, the first time, this guy has to cover everything. Has to print all columns. Column 0, column 1, column 2. So it's printing column 0, column 1, and column 2. Then this guy is done. Comes to this line. This line says print a change of line. It's printing here. You're about to print in this point. You come, I is 1, you go ahead and do all the things. I0, J0, J1, J2. And then change of line. You come here. Got it? Clear? All of you?
Yes.
Okay, good. I'm still not happy guys. I'm a very picky person. Because I would like to have like something like this. Because in my TicTacToe I like to see the bars separating, right? Correct? And I don't like this that much because I like to have some lines separating each of the... It would be nicer if I did something like this, right? Why? Okay, not a problem. I'm cool. I'll do this. Let's see if that helps. Yes. Getting better. Getting better, right? You understand what I'm saying? I want to simulate, try to give the look of the TicTacToe board, right? Now I see that I have an excess. I have an excess here because I don't need this bar. And I have an excess because I have this extra line. So let's do little by little. How do I get rid of the last 5? The last vertical line. 5 is a vertical line. Sorry?
You would concatenate it to the beginning instead of the end?
No. We're not using strings, we're just using pronouns. Some validations.
For loop twice?
I'll show you. Regardless of where I am, I need to print each element. Is that right? And all I will do is say this. Check this out. It's just a little bit of tricky. So regardless of where I am, regardless of which column I'm talking about, I need to print the element. That's understood, right? Now, if I am on the first or the second element, I need to add the pipe after it, right? But if I am on the last element, I do not have to, right? So what I will do is the following, say, if the current column is different from the number of columns minus 1, right? Meaning, it is not the last column, right? That's what it means, right? Correct? If it is different from number of columns minus 1, meaning it is not the last column, right? Then you have to add the 5. So what you do is, you can all that print, just print, and put the extra 5. Here's my column. We need some of the Got it? Is that clear?
Yes.
So now, looking better. Right? Is that clear, guys? Do all of you understand what I'm doing? This is just makeup. Women are better for this than we are, guys. Just making the code look nice, the output look beautiful, right? So, now here I have to do something similar. Did you learn the trick, guys? How could I do so that the last column, the last row doesn't print that?
Alright.
Not hard. All I have to say is if your current row is different from the last one, right? It is not the last row, and add this guy, right? Correct? Now we want the list successful to appear below, right? We don't want it to be messed up. So what you can do is just add here outside. Once you have printed everything, put a couple of change lines so you pick out the list successful. And that's about it. Got it? Now I don't need the any anymore, right? I don't need the any anymore, right? Sorry guys, some of you are gonna feel sad, but I have to remove it. Because the any was just to make it visually easy to see. Now this is how the table looks. Nice? Yes? Okay, so I come to my game here and say, oops, the create board is no longer a problem. Nice. You can leave the comment if you want, so it doesn't really matter, it doesn't hurt. Now, here you come and concentrate on the start game. Now, do you see how I'm solving this problem? I'm going piece by piece, right? The first thing is how the heck do I deal with the board? Did I worry about the game itself? No, I haven't worried so far about how do I switch turns, how to determine the winner, all that. It's not my problem for me. I'm focusing one thing at a time. My problem is, how the heck do I print the board? How the heck do I create one? How do I initialize it? That was all my focus. Got it? I'm done with that problem. Now, I focus on the next problem. That's my only problem now. No more. I see one problem at a time. That's the only thing I have in my head. Now, start game. Okay, let's see what I need to start game. I will need something like a piece to determine if it's my piece, maybe an X, maybe say this is a piece circle and we want to play, right? So I have to indicate a piece, right? Now, what else do I need? We need to swap turns, right? So that first X plays, then circle plays, then X plays, then circle plays, and so on and so forth, right? How can we manage that? Swapping turns. Yes, but how can I determine whose turn it is?
Very P1, P2. And
Sorry?
then distinguish them by P1, P2, and then make sure that
How do I know if it's P1's turn or
You can have an increment counter, so every time somebody plays, the counter goes up one. You can have odd and even numbers. If it's odd, P1 goes. If it's even, P2 goes.
Excellent. Do you hear what he said? You get a point for that. Do you hear what he said? He says we can have some sort of counter that indicates how many times a person has played. And if the current, if say we start with counter 0, if he plays, then it becomes 1. Now she plays. If she puts the counter to 2, so it's even, it goes back to him. And they keep swapping like that, if it's even or odd, because the counter will change between the two of them. Now the first idea that comes to your head is let's do a for loop, because a for loop does counter. But do you know how many times are you going to play? Some people again here become crazy and tell me, yes, I know they're going to play 9 times, because there are 9 spots. Is that right? No, because somebody could win on the 7th move, right? Correct? You don't need to fill out the whole board for having a winner. Moreover, what if they are playing and he chooses a spot that is taken by her? He has to choose another spot, right? It would be stupid to give her that turn now. Got it? So we have to take care of all those things. Since I'm lazy, I don't care to count that carefully, I don't know how many times it's gonna last, I will just say while true. Because I will just pretend the game goes forever and I will break it after I have checked that somebody won. Okay? Some professors don't like that while true and become stupid and say, oh, you have to put while not false, same thing. Okay? So, I'm not mentioning names, guys, don't get offended. So, now, moreover, I don't like the fact that you said a number of moves. Because like I said, he might have made 2 moves and only one was right. So I shouldn't count 2 moves, just 1, right? So what I will go is by this, simple. I have a board of 9 spots, right? Say the board is virgin, totally empty. 9 spots are free. Say he starts playing and he puts an X on 1 spot. And he gives a good corner because he can be also dummy and saying, put on position 10-10. We don't have 10-10, right? Let's say he gives a valid coordinate, say 0-0. He puts on the first corner, an X, right? Only then, when a spot of the board has been inserted, only if something has been successfully inserted, I should say, Davis, now it's your turn. Got it? Is that clear? All of you? Yes?
Yep.
So what I'm going to have is some sort of counter of how many spots are taken. Got it? So we have a counter here, number of spots taken. Initially 0, for example. Because obviously it's empty, right? Nobody has taken anything yet. So, I will do this. I will say, if number of spots taken, how do we check if it's even? Like this, right? You know this, right? Correct? Even, because the remainder is 0, right? If it's even, let's say I'm going to say piece is going to be the turn of, say X. Okay? Else, say piece is going to be, say O. Got it? So now I have solved the problem of determining whose turn it is. Right? Correct? Okay, what else does, okay, let's say we are playing this game. So, say these 2 guys are playing, say he starts, when he's X, he starts, right? Once he knows he's the one to start, and he knows his piece is X, and she knows that her piece is circle, and she knows that she has to go after him. Once that's clear, what's the next thing to do? Well, it's time to start, right? He should start trying to insert his piece, right? Now, why do I say try to insert, and not just insert? Because what he has to do now is ask for coordinates. I have to ask him what's your coordinates, right? To put his piece, right? And I say try because he might, after giving me coordinates, his coordinates might be wrong. Got it? He might tell me coordinates that are out of scope, or he might give me coordinates that are already taken. Got it? So what I will do is simple. Just say, let me declare them outside to make them nicer. X, y. I need to ask for coordinates, right? X, y. So I will say X equal, you know this, right? That's classic thing, right? Same thing. I will do all that all in one line. Okay, guys? Same thing. Remember I did it with a string and then I parse it? Remember?
Yeah.
I'm going to do it all in once, okay? It's the same thing. I just want to save time. Enter X. And then I'll do the same here for Y. So, okay. So I know whose turn it is, and I know the coordinate where that person wants to put the piece. I'm in good shape. Now, what do we need to do now? I need to try to insert. And again, I say try to insert because I have no guarantee so far of what X and Y is. I don't know if X and Y are outside my board, or I don't know if X and Y are positions that are already taken. So I will just say try to insert. If I don't have a boolean, just to make it step by step, say inserted. And this boolean will get the answer of try inserting this piece into position X, Y. You understand what I'm trying to do? Right? I'm saying there will be some method. I don't know yet how the heck it's going to be implemented. I have no clue. But there is going to be some method that is going to try to insert a given piece, X or circle, depending on number of spots, right? And it's going to try to insert this piece into this position X, Y. And this method should return true if it could be inserted or false if it couldn't. Got it? So far so good?
Yep.
Okay. Now, if inserted is true, I'll do something, right? I have to do something else. Else, what do I have to do? Show a message, right? Show a message dialog saying you entered a wrong. I have to put a cordial message, right? Wrong coordinate, right? Right? You don't have to be that nice, just like that. Right? Do something like this, right? If I you, right? If I you. Okay. Okay. So, and this is nice. This is good. What we're doing is good. You know why? Our logic is going little by little. It's good because of this. You try inserting this piece into this XY. If it is true, means you could insert. Now you have to do something because you have to check now if that maybe generated a winning move, right? Correct? Maybe that was the last move, generate a draw, or maybe they generate a winning move. We don't know. We have to do something else. But if it's wrong, if this is false, meaning it could not be inserted, all we have to do is say wrong coordinates and come back here. Number of spots will not have changed because I'm not doing anything with number of spots. So I will give the turn to the same person. Got it?
Right.
And ask coordinates for him again and try to insert again on that same piece. Got it? That's correct, right? Is that clear? Yes?
Yeah.
Okay. Now, if it was well inserted, the first thing we need to do is increment the number of spots taken because something has been inserted. Right?
Yeah.
Do we have to increment the number of spots taken here in the else? No, because nothing could be inserted. Doesn't make sense, right? Now, you have to be smart and analyze this a little bit. Since I'm saying number of spots taken plus plus, if it was inserted, then that means that when if that person doesn't win, when you go back, number of spots has changed, so it will swap the turn to the next player, and that's the way it's meant to be. Got it? Yes? It's working, right?
Mm-hmm.
Now, question: do I need to say equal true, or can I just write if inserted?
You can just leave inserted.
You know that?
What?
When you are dealing with Boolean variables, you don't need to compare equal true. If you just put a Boolean variable, that's enough, because the Boolean variable already carries true or false. Got it?
Mm-hmm.
You don't need to do that. This guy is falling asleep. Wake up, man, wake up.
Is it by default false or true? By default?
Booleans are by default false, but in this case, that's not a problem.
Oh.
What I'm saying is, that Boolean insert has a value, because it says Boolean inserted equal. It already has a value, right? At this point, when you're here, Boolean inserted has already a value, because insert already got a value from here. So this guy already carries a true or a false. So you need to do this. You just put it like this. If it's true, you get in. If insert is false, you're going to come here. You understand what I'm saying? So you don't need to say equal true. That's a mistake in Booleans. I just put it because it's easy for you to understand. But now I'm going to remove it. Okay? I will not, but it's not for now. Yes?
So if you wanted false, you deny, you would just put them.
Correct. If I want to check if inserted was false, I would do like this, not insert. Got it?
Oh, I understand.
Got it, guys? Yes?
Yep.
If I were checking if it was not inserted, I would say not inserted, because that will make it true, right? Got it? Okay. If it was inserted, the number of spots taken has to increment. What else do I have to do? I have to check if the game is over. Why? When somebody inserts a spot successfully, chances are that this person just put a winning move, right? The last winning piece that was needed to generate a winner, right? That's one chance. The other chance is that this person fill out the board and the game is over. Got it? Correct? Regardless if the person generated a winning move, or if the person just made a draw, because there is nothing else that can be done, the game is over, right? And I should exit this game. I should break this while true. Got it? So what I will do here is have something like this. If game over, or if check game over, check game over. And this would return true or false also, right? I could put the message right there. If this move of this piece in this position, x, y, with this number of spots taken, actually we'll leave them for now. If this generates a game over, I need to break. I don't need to continue doing any loop. Right? And that's about it. Is that clear? I ask for a coordinate. I try to insert it. If it was correctly inserted, I increment the number of spots taken because obviously one spot has been taken, right? And then I check if this piece in this position that was just inserted generated a game over. And if that's the case, just break it. If this method returns true, meaning it is game over, either draw or winning, I break. If this is false, then I will simply go to the beginning and continue playing. Get out of the if and go back to the while. Got it? How hard is to write this code, guys, so far? Simple, right? It is not hard. I'm not doing anything complicated yet. Right? This is exactly how I want you to program. If you're capable of solving a problem like this in my exam, maybe give you a problem like this in the exam, and you're capable of writing this much, I'll give you 95% of the credit. Might sound like, Professor, are you crazy? Because you haven't checked winner diagonally, horizontally, you haven't done any of that crap, right? You haven't even inserted a piece yet in the table. You haven't checked if there is a draw. How can you give me 95%? Because this is the logic, guys. This is the meat and potatoes of the program. Trust me. If you're capable of conceptualizing everything and putting it into code like this, you're mastering Java. And not only Java, any programming language. Yes, sir?
How are your exams going to be then? Are they going to be like filling answers like that? Or?
No, I never do that. My exams, I will give you a bunch of questions to solve, to code. I'll tell you, write a method to perform this and that. Okay, write a program that is capable of doing this and that.
You write it by hand?
By hand, yes. So you have to bring a pencil and eraser because you're going to be erasing back and forth all the time. Yes.
Are we gonna have like a kind of like a practice?
Yes, people always ask me for reviews, and my answer to the reviews is simple. The reviews is for you, right? So when I come that day for the review, you have to ask me questions. If you don't ask me questions, I'm gone in 5 minutes. You have to ask me questions. Yeah, I mean, the review is supposed to be for the students to have studied everything and come up with doubts, right? Things that they couldn't do. So you give me your problems, I'll solve them for you, and you go prepared. If you come here and expect me to teach you Java 2 all in one day, forget it. It's not going to happen. Okay? You're wasting your time and my time. So you come and ask me questions. Bombard me with questions. Okay? Yes?
So in a test, if we make a reference to an object like, can be to board.java, right? Or we also need to write up the objects to fit in the testing.
If you need them. In this case, for example, you just need one object, board, my board from the board. That's it.
And it's mostly just for drawing, so, because we're drawing, in the board, we're drawing the board. Would that also be considered like a new things that we require?
No, I want to see pseudocode that is like this. This is like
Right.
pseudocode. Okay?
Does that
This is like very close to pseudocode, guys. You see these two things are underlined? Right? Because I haven't implemented them. So now I have to solve this guy, I have to solve this guy, right? These two methods. These are my problems now. This is what I was telling you. Remember the big rock? I split one piece was to manage the board, right? And even inside the board, I split the piece in pieces, how to create the board and then how to initialize the board, right? Now, the whole problem of the TicTacToe has been summarized to two little problems. How the heck do I insert a piece? And how the heck do I check game over? Which one do you want to do first? Whichever you think is easier. But just focus on one at a time. So my problem now is just these two. I will try solving this first, because this seems easier. Inserting a piece seems easier. Now, how the heck do I do this? That's my problem now. That's my only problem. I don't worry now. Imagine you were hired to make this program, right? But it's a team of people, and your boss tells you, I want you to implement that method. So you don't have to worry. This method could equally be maybe for the Monopoly game. You don't care. Your problem is simple. Somebody's giving you a piece and two coordinates. And it's asking you to try to insert that piece in that coordinate. And return true if you could or false if you couldn't. Simple like that. Isn't that much easier than solving the whole TicTacToe? Way easier, right? Way simpler. Now, I'm trying to insert this piece into this coordinate, right? Where am I trying to insert this piece?
Into the array.
In the board, right? So shouldn't this method be part of the board? Of course, because the board should know about himself, right? So this should be something like my board that try inserting, right? Okay, let's add that to the code. So you realize that it's easier if we do this from the board, right? Correct?
Yes.
Now I don't have try inserting, so I will come here to my class board and implement this method. Okay, I want this to return a boolean, right? So public boolean try insert. What do we try insert? I'm trying to insert a character piece, and I'm trying to insert in this position, right? Correct? Okay, for me to insert it will be as simple as this. Table xy equal p. That's it. That should be the insertion, right?
Right.
Correct? But if I do that, I wouldn't be checking if the coordinate is correct, and I wouldn't be checking if the spot is taken. So that would be wrong, right? So this should be done only when you are sure that the spot is available, right? Okay. What you do is this. You write pseudocode first and say, if good coordinates and available and the spot is empty, then you do insertion, right? Correct? Got it? And right after doing insertion, that means that you could insert, right? So what you can do is just simple say, return true, because you could do it, right? Correct? Else here means that it was not good coordinates or that the spot is not empty, right? Regardless, that means that you have to return false, right? So here you will say return false, right? Do we need the return, the else?
No.
I don't need it, right? Because if it's not the if, then it's going to jump to this anyway, right? Now I have to do good coordinates and spot is empty. My problem is much simpler now. Two little problems. You see? My big problem of trying to insert has been reduced to two little problems. How the heck do I check if the spot is empty? That's simple. All I have to say is spot table at xy equal empty. Right? Let's check if the spot is empty, right? How do I check if something is good coordinates? Well, good coordinates means that it's inside the range, right? Inside range, what, x comma y, right? Okay, that's it. Now my problem has been reduced to how the heck do I check if something is inside range? And return true or false if it is, or false if it isn't, right? That shouldn't be hard. Public boolean inside range. I'm receiving x and I'm receiving y. Right? How do I know if it's inside range? Well, if x is inside range, then x has to be larger or equal to 0, right? Because negative x doesn't work, right? It has to be larger or equal to 0, right? What else? Well, x has to be less than the number of rows. Otherwise, it's not a valid row, right? What else? Exactly, you got it, guys. Y has to be greater or equal to 0, and y has to be less than the number of columns. Right? That means it's inside range, right? If so, I return true, else I return false. I don't need the else, you know that, right? Right? You got it.
Does that method need to be above the one above it? You know, since you have inside range before you define it?
In Java, you don't have to. If you want, put it above. If that makes you happy, put it above. But that doesn't make any change. Okay? Now, the cool thing is that some people tell me, Professor, I can do it better than you're doing. I can just say return in all these big conditions. Is that correct? Just imagine I didn't put these two lines here and I just put return here instead of it. Is that correct?
Yeah.
Yeah, because all this is going to tell me true or false, right? All this is going to, if one of these fails, it's not valid, right? So it would return false. So I could say return and return that. Got it? Now, quick question. Does it matter if I put it this and then this? Or if I put it that way? Does it matter if I swap them? Or is it the same thing?
Same thing.
All of you fail. It's wrong. If I put this here, and then this, like if I swap this, what if somebody tells me 100, 100? Then I will try to look at position 100, 100, and the program will crash because I don't have that coordinate. Got it? Right. But if I do it in this way, here I will detect it's wrong. In Java, I will not have to check this side.
The method you can put it anywhere, but the inside you have to.
The conditions, yeah, these conditions is important. Remember, the AND works like that. If one side is already false, Java doesn't need to check the rest, right? Because the AND requires everything to be true. If one side fails, doesn't have to look at the rest. Got it? Yes?
Why don't you have to set that top statement to equal true? What if you were looking for false, for example? If you wanted, let's say, inside range to be false, let's say if inside range, how would you set it to be false? Let's say you wanted it to be false and one true.
If I wanted it to be
Just
false,
random. If you wanted that variable to be false while the other one true.
I would say if not inside range.
Okay.
You just put the exclamation mark on top of inside range. Before
Got
it's
it.
not inside range. That's one of you asked me that before, I think. I think you asked me, right, Carlos? Yes, Darren.
Can you explain that again?
The order of these two? The order? Okay, I was saying, if I put table of XY here, and I put inside range here, the program might crash, because if somebody enters 100, 100, I will try to check, is table of 100, 100 equal empty? I don't have that position, so Java is going to crash. It's going to make the whole program stop. But if I put it like this, here Java is going to detect, because this method will detect that this is wrong. So we'll come this with false. It will not have to check the rest. So this will never be checked and never crash. Got it? That's why it's important. Is that clear, guys? The order is important. So far so good? Yes.
When you're checking if it's inside the range, it shouldn't be x is less than or equal to in rows and y is less than or equal to?
No, because remember, your rows go from 0 to rows minus 1. And your columns go from 0 to columns minus 1. Got it? If you have a matrix of 3 by 3, for example, your columns are 0, 1, 2. And your rows are 0, 1, 2.
Okay.
You always go one less than the number of, you got it, right?
Yeah.
Is that clear, guys? I know you want to leave, but let's try to have let's try to at least get this started.
Comes up with
How
a
do we check
solution
if
so
game is
fast,
over?
I
This
can't
is my
come up
problem
with
now, right?
solutions.
Now, who do you think will have the information if the game is over? Obviously the board, right? Because the board has all the pieces inside, right? So I need to do something like this also, right? Correct? Now, for checking if somebody won, I have to check the whole board and check this piece, right? Correct? Do I need X, Y? Most likely I don't need it because I will just check for that piece in all directions, right? Correct? With that I can determine if somebody won, right? Correct? Now, if nobody won, what is the other possibility for the game to be over? So there is a draw. How can I detect if it's a draw? If the number of spot taken is 9, right? Correct? Correct? So this method needs to have the number of spots taken, right? Correct? Otherwise, how can he determine that the game is over, right? Got it? Yeah, it might. It might also find it another way. Remember, the board has a whole board. So I could check all the board and see if all the spots are different than space. And then I can also determine, right? But it's more work. That variable already carries that information. So I could just pass it, right? Is that clear, guys?
Yes.
All of you?
Yep.
So now let's go for this one. So I come here to my board and I'll do the method. Public Boolean check game over. Here I have a piece and I have the number of spots taken, right? Okay guys, when is the game over? Well, the game is over if there is winner with this piece, right? Or if the number of spots taken is
9.
or draw, or there is draw. Right? How do I check draw? With the number of spots taken, right? If there is winner or there is draw, the game is over, right? So I return true. Otherwise, I return false. Got it?
What would
Now,
happen if you went with where you were writing originally, number of spots taken equals 9?
sorry?
You're in the middle of writing number of spots taken instead of where it's dropped.
I could do that too. I could do that too. I'm just putting in like more simple. You can have this straight if you want. Now, which one, now our big problem of the whole TicTacToe has been summarized to just how to determine a winner, how to determine a draw. Isn't that much simpler? You see how the big thing, I mean, putting it little, right? And then a bunch of methods, right? That's modularization, okay guys? That's modularization. Now, how the heck, which one is easier, winner or draw? So let's do draw first. Public Boolean, there is draw. Okay, number spot taken, right? How do I know if somebody, if there is a draw? Simple. Number spot taken is equal to number of rows times number of columns, right? Let's say 9, but I can multiply because I want to make it 9, right? Then return. Else return false. I don't need the else, you know that. Got it?
Now, Professor, aren't you gonna run into a problem where if he wins on the 9th spot, what if he hits TicTacToe on the 9th?
Good question. I know what you're saying. I will go quick because we're running out of time. He's asking, I know what you're asking. He's asking, what if on the 9th move, right? What if on the 9th move, I won? Will you detect that as a win or will you detect that as a draw? Because the table is full. That's your problem, right?
Yes.
My code is smart. My code will detect that you won. You know why? Because before checking for draw, I'm checking for winner. You see the condition? I'm putting this first. I was taking that into account. Got it? Is that clear, guys? Yes. See, you can read your minds. So, look. Now, how the heck do I determine if there is a winner? I see this piece, right? How the heck do I determine if there is a winner? Well, somebody wins. If somebody wins horizontally with this piece, right? Or if somebody wins vertically with this piece, or if somebody wins diagonally with this piece, right? Return, true, right? And here, even before returning true, you can put your nice message, right? Saying, oh, you won, whatever, right? So you can say here, the option. Okay. So here you can put something like this is the piece, right? Won this game, for example, right? That's the piece that won, right? Correct? Regardless if you want horizontally, vertically, you can print piece won this game, right? Else you return false because nobody won. There is no winner, right? Got it? Same thing here. If you want, you can put a nice message here because we want to put messages also to indicate. So before returning true, that means there is a draw, right? You can put a message something like you can put draw game, you go suck, right? For example. So my problem now has been summarized on how to determine a winner horizontally, vertically, or diagonally, right? So what you do is just focus on one at a time. Say my problem is only just one little problem. How the heck do I determine a winner horizontally? With the public boolean, horizontally, and here you write char p, and you try solving it. Do you want to spend 3 more minutes and finish this, or do you want to leave?
No, finish.
Yeah?
Go ahead, finish.
Okay. Shouldn't be hard, guys. Look, it's simple. You have like this, right? How do I determine if a winner won horizontally? You have to check this, and then that, right? So I need to check this, and this. And then move to the next row, right? Isn't that like printing? Isn't that like printing? So you can use the same two for loops that I use for printing, right? And as I check each of these guys inside, instead of printing, I start counting if they are equal to my piece. And before moving to the next row, check if that counter is equal to number of columns. Then that person won. Is that clear?
Yes.
Yes or no?
Yes.
All of you?
Yes.
So, I'll do what you do best, guys, copy pasting. Right? So we have a counter. So the counter is simple. Check this out. The counter just does this. The counter just says in counter. Before checking each, when I am here, look, when I am here at the position where I'm writing now,